Hey Algebra 2, welcome. Today we're going to learn about permutations and combinations. So permutations and combinations are different counting methods. So over here on the first one, how many ways can you list possible combination of the letters A, B, and C if the order matters? So when the order matters, I'm saying that AB and BA are distinctly different because the order matters here. I'm saying that BC and CB are totally different because the order matters. And then the only one that I am missing would be AC and CA. So I don't see any other combinations that I am missing. So when the order matters, I can make 6 possible combinations. And when the order matters, this is what we call a permutation. The other type is where we want to list the letters A, B, and C, but the order does not matter. So like right here when I said A, B, and BA are distinctly different, here it's saying, no, that's the same thing. So I have AB. In this group, B, C, and CB are distinctly different. But over here, when order doesn't matter, so B, C, and CB are the same thing. And then finally, in the last one, AC is the only other one. So when the order does not matter, we only have 3 possible combinations. And this is called a combination. All right, so fun fact. Back in the days when you used to have a locker and you turned it, does the order in which you enter your 3-digit code actually matter? Yes. Yeah. So your locker combination is actually not a combination. It is actually a permutation. So we're going to teach you how to use your calculator now. And so we're going to start with permutations. And so we are looking for, we're going to use this probability button. And in permutations, order matters. So you'll see on your calculator that there's a lowercase n and r. And so we need to know, what do those mean? N is the total number of items to choose from. R is going to be the number of items selected. So here on this one, this is what it looks like when you do it on the Desmos calculator. So in your calculator, so if you had 12, which is your N, which is your grand total, and then you would have 3, which is your R, which is the number that you select. So here's how you would enter this into your calculator. Let me clear that off. All right, so you're going to enter the 12 first on your calculator. Everything is in the PRB button right there, so you're going to hit the PRB. We're going to start off with permutations. In the next section, we're going to do combinations. So you would just arrow over to select the specific kind of probability that you want. So I'm going to hit the enter button, and then I want to select 3 things, so I'm going to put my 3 in there, and I'm going to hit the equal button, and so that answer is 1,320. So once again, everything is housed right here in your PRB button. You just have to remember to put in your first number, and then the PRB, and then the second number. All right. Question number 1 says, in how many ways can 5 teams in some league finish in the standings? Okay, so this sounds like n equals 5 because that's the total number in the league. In this case, R is also 5 because we are going to select all 5 teams. So it is possible that those numbers will be the same. So in your calculator, when order matters, and so coming in first, second, or third, order matters. So we're going to go 5P5. So in your calculator, clear that out and give that a try. 5, probability, permutation, select 5. 120. So there are 120 ways that they could finish. So the permutation, we can do a lot like we did the fundamental counting principle yesterday. So this would be like, how many different teams can finish in first place? That's what is going in this first box. 5. Then how many teams are left to come in second place? 4. How many teams are left for third? 3. How many teams are left for fourth? Sorry, my bad. And then how many teams are left for last place? Just that 1. So I teach it this way as well because when you take the SAT, you probably won't actually need your permutation or combination button. Almost every problem on the ACT you can do in this format. So if you feel like the numbers are small and the order matters, you could always just do this. So you could always fact check yourself. Take 5 times 4 times 3 times 2 times 1. Does that in fact match, and do you in fact get 120? Yes. So you have choices here as long as order matters. As long as order matters, you can do it a couple different ways. Number 2 says, in how many ways can the top 3 horses finish in a field of 13? All right, so the top 3 horses, that's like how many we're going to select. So that's like saying R equals 3. In a field of 13, that's the total. So that's saying your N value equals 13. So you could write it out like we did yesterday. First, second, third. So I have 13 horses that could come in first place. I have 12 horses that could come in second. And I have 11 horses that could come in third place. When you multiply those numbers, what do you get? Good. 1716. So there are 1,716 different ways that horses can finish first, second, and third if there are 13 of them. Let's fact check our calculator. So order matters, so this is definitely a permutation. And we would say of 13, select 3. So try entering that in your calculator. 13, the probability button, 3 equals Number 3 says, how many ways can 5 cards be selected from a deck of 52 without replacement? All right. Without replacement, and I'm starting off with 52 cards, so that is my total. So that is your end value. 5 cards will be selected, so that is, I'm sorry, that should be a 5. I don't know. All right, so 1, 2, 3, 4, 5. So if you were to do it like we did yesterday, how many choices do you have for the first card? 52. This says we aren't going to replace it, so we aren't going to put it back. So in that case, how many choices are left for the next card now? 51, and then 50, and then 49, and then 48. And so this is a problem where you could just simply do it like this and multiply the numbers together. And you should get a large number of 311,875,200 different ways that you can select 5 cards out of a standard deck. All right, let's make sure that we did it correctly. Is this a permutation problem? So if you do 52 permutation 5, do you in fact get this same big number? You do. You get that number right there. How many ways can 10 different people line up in a row for theater tickets? All right, so you could do it like you did here. So you could go 10, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. So while the order doesn't matter, once one person is in the first spot, then nobody else can take their position. So in a way, the order doesn't matter, but once someone is there, then like nobody else can go there. So you could always do it this way. 5 times 4 times 3 times 2 times 1. So if you multiply those numbers, you should get 3,628,800. If you did it using the formula here, so in this case, your N equals 10. There are 10 people to choose from, and R also equals 10 because we're going to select every single one of them. So this would be the permutation of 10 select 10, and you could try it in your calculator, and you should in fact get that number. We're now on the back side, and now we are going to do combinations. Combination, your order does not matter. All right, so in what situations would the order not matter? Think of a pizza. So you have a pizza, and you want to choose sausage and pepperoni and mushroom and onions. It really makes no difference whatsoever if somebody starts piling on the onions first or the pepperoni first. Think of a committee. If you have, so in my class right now, there's like about 25 people. So if I wanted to pick 4 people out of here for my committee, it doesn't matter if I choose these 4 girls like first, second, third, fourth, or second, third, fourth, first, that like on a committee, it doesn't matter who's chosen first or fourth, because you're all just on one committee and you're equal. All right, so on your calculator, under the probability, there is a C button, and it is still the format NCR. N is still going to be the total, just like the other side, and your R is still going to be, that's the word select. Yep, that says select. Number 5, you want to make a pizza. There are 15 toppings to choose from. You decide to select 3. How many different pizzas can you make? I know that says toppings. It's supposed to say toppings. My bad. All right, so N equals 15. That is the grand total. You are going to select 3 of them, so that is your R. So this is the combination of 15, select 3. There is a formula that goes with it that I don't teach anymore. We just use your calculator. But what is important for you to distinguish is that when you have a combination problem, you can't make the little lines like you did before. It doesn't work. You can only do that when the order matters. So you put that in your calculator, and hopefully you got 455. Do you concur? Yes, they're concurring with me. We have a reading list with 20 books on it. In how many ways can you choose 4 books to read? So back in the day, for to be an AP English, you had to read a bunch of books on the summer reading list. So if they said you have to read 4 books out of the 20, it's over the summer. Nobody cares. Like, it's just to experience and be familiar with these books. It doesn't matter the order in which you read them. It just matters that you get them done. So the order does not matter here. So your N is your 20, and your R is your 4. And this is a combination problem because the order doesn't matter in which you read them. So in your calculator, you're going to go 20, hit the combination button. I haven't done a combination one, so I'll put that on here. I'm going to do 20. I'm going to hit the PRB button for probability. And on these, you're going to have to arrow over to this NCR and hit the equal to select it, and then put in 4 and enter. You should get 4,845. I'm going to do the rest, and you can come back and check the notes. We're going to jump to the bottom here, and at the bottom it says, would you use permutation or combination? So you have to read through these, and you have to figure out, does the order matter or not? So when you're looking at this, you are asking yourself, does order matter or not? Because if the order matters, that means you have to select a permutation. And if the order does not matter, you have to say, hey, this is a combination problem. We've had much debate in the math hallway on the first one. So you could probably argue this either way. You would like to test 3 of the top 10 ranked laundry detergents. In how many ways can these be selected? Okay, so my initial answer sheet was that this is a permutation because I'm dealing with ranked laundry detergents. A coworker suggested, well, I mean, you're just going to test 3 of them. Does it really matter if you choose tied first or cheer first? Does it really matter? And so it's like, well, that is a really good point. So now I'm led to believe this is probably actually a combination problem. I am certain that this question is not going to appear on the test because I think it is vague and it is open to debate and interpretation. The next one says an employer must choose 4 equally qualified candidates from a pool of 15. How many ways can the applicants be chosen? All right, so since they are equally qualified, that led me to believe this is a combination problem, because it doesn't matter which one I choose. I'm going to just, the order does not matter. The last one says I have a president, a secretary, a treasurer. How many ways can this be done? So anytime that you have a ranking or you have a position, the president's job is very different than the secretary's job. So being selected for the president matters. So this one I decided was definitely a permutation. Because the order matters. And check back with the notes. Thanks.